Application 1. Uniform rectilinear motion. Consider an object M moving along the x-axis. The time equation of the motion of the object is x equal 5t minus 15, where x is in meter and t in seconds. Specify the nature of motion of M. Indicate the algebraic value of the velocity and the initial abscissa of M. Deduce whether M is moving in the positive direction or in the negative direction. Calculate the abscissa of M at t equal 1 second and t equal 4 seconds. Deduce again whether M is moving in the positive direction or in the negative direction. Calculate the distance covered by M during 1 second to 4 seconds. 4. Calculate the instant at which M reaches the abscissa x equal minus 5 meter and reaches the origin O. Specify the nature of motion of M. Specify means you need to justify your answer. It's uniform rectilinear motion since the position time equation is in the form of x equal vt plus x naught. 2.1 indicate the algebraic value of the velocity and the initial abscissa of M by comparing x equal vt minus 15 to x equal vt plus x naught. V equal 5 meters per second. How did we know that it's meters per second? Because x and t are expressed in meter and seconds respectively. And x naught is equal to minus 15 meter. Deduce whether M is moving in the positive direction or in the negative direction. V equal 5 meter per second is greater than 0, it's positive, then M is moving in the positive direction. Calculate the abscissa of M at t equal 1 second and t equal 4 seconds. At t equal 1 second, we express this position as x index 1 to show that it's at t1 equals 5 times 1 doing the substitution in the given time equation. Minus 15 is equal to minus 10 meter. At t equals 4 seconds, x4 is equal to 5 times 4 minus 15 equals 20 minus 15, yani 5 meters. Deduce again whether M is moving in the positive direction or in the negative direction. So if you consider the x-axis and the origin O, unit vector I, and suppose that we take a scale magnitude of I vector equals 2 meters. Now if you want to study the position of this moving object at t1 and at t4, so we got that x1 was equal to minus 10 meters, so it is according to the scale, it is 5 boxes or 5 centimeters. So here it is minus 2, this is minus 4, this is minus 6, and x1 is minus 10, so we still need to continue. This is minus 8, and finally this is minus 10. So at t1 the object was at this position, then at t4 it's 5 meters, so it is in the positive sense 2, 4, and 6. So x4 is between 4 and 6 here. So the object is moving from x1 till x4 in this direction. That's why since x4 is 5 meter greater than x1, which is equal to minus 10 meter, thus M is moving in the positive direction. So whether we consider the speed or the velocity or the change of the position, we obtain the same result, which is that M is moving in the positive direction. Now 3.3, calculate the distance covered by M during 1 second till 4 seconds during this interval of time from 1 second till the 4th second. So the first way here is to calculate D by using the formula x final minus x initial. X final, which corresponds to the final instant of this interval of time. It is x4 minus x1, which is the position that corresponds to the initial instant of this interval of time. Doing the substitutions now, x meters minus 10, it is x meter plus 10 meters, so the distance covered is 15 meters. And we can check it on the graph here. So it moved from this position to this position here. So let's count 2, 4, 6, 8, 10, 12, 14, 15. Or the second way is by using, because it's uniform rectilinear motion, we can use this formula to calculate the distance, which is d equal v times delta t, The speed is constant, 5 meters per second times t4 minus t1, t final minus t initial. So the duration of this interval of time is 3 seconds and the distance is 15 meters. Calculate the instant at which m reaches the abscissa x equal minus 5 and the instant at which it reaches the origin O. Reaching x equal minus 5, we can substitute in the position time equation and we do the calculations here. Minus 5 equal 5t minus 15. Bring minus 15 to the other side to keep 5t alone. It becomes a plus 15. So plus 15 minus 5 is then equal 5t. 10 over 5, divide both sides by 5 so that the coefficient of t becomes 1. And we obtain that t is equal to 2 seconds. So after 2 seconds from the initial position, the moving object m reaches abscissa x equal minus 5 meter. Then as it continues moving, it's going to reach the origin O. So the origin corresponds to x equal to 0. Doing the substitution, solving the equation, we get that t equal 3 seconds. So as it continues, after reaching x equal minus 5 meter, it continues 1 second later, it reaches the origin O. So 3 seconds starting from the initial position.